As another example of iterated integration, or applications of it, let's look at how we can calculate some volumes in space. Here's the setup. Suppose that we want to find the volume of a solid which is bounded below by a region R in the xy plane. So imagine this rectangle to be living in the xy plane. And above by the graph of a function z equals f of x and y. So here, the function f of x and y might be this curvy surface above the xy plane. And I want the region which sits below that purple curvy surface and above this region R. So the bottom in my picture is a rectangle, and then I have four vertical sides, which are almost rectangles, only they have curvy tops, and then the top is totally curvy. So if you go through a bunch of theory using Riemann's sums, by the way, this whole solid is what I'm calling Q, then you find out that the volume is equal to the double integral over R of the height function f of x and y with respect to area. And as usual, this dA is representing either dx dy or dy dx, depending on whether you want to slice vertically, whereby vertically I mean parallel to the y-axis, or horizontally, parallel to the x-axis. So as an example, let's find the volume of the solid Q in the first octant bounded by the coordinate planes and the plane x plus y plus z equals 2. So we'll spend a few minutes getting an idea of what the picture looks like, then we'll set it up and carry out the integral. First of all, let's look at the picture. The first octant is the portion of space where the x, y, and z coordinates are all positive. So I'm going to represent that by just drawing the positive x, y, and z axes. And then the first octant is the part which is facing us. Now x plus y plus z is a plane. Let's find out where this plane intersects the positive x, y, and z axes. To find out where it crosses the x-axis, I set y and z equal to 0, and I get x equals 2. To find where it crosses the y-axis, I set x and z equal to 0 to get y equals 2. And you can see that it crosses the z-axis at 2 as well. So since this is a plane, it will cut each of the coordinate planes in straight lines. So we can see that the region Q has one triangular face, which is this blue triangle here. It also has a triangular face on the bottom, which is a right triangle, one on the left side, which is a vertical right triangle, and one at the back, which is a right triangle. So this is a four-sided pyramid. Now, in terms of what we were doing over there, the top surface, z equals f of x and y, is going to be this tilted triangle here, where we can rewrite it as z equals 2 minus x minus y. And the region R is going to be its projection down here in the xy plane. So I might want to draw a picture of R all by itself, just in the xy plane. It's going to look like this. It's going to be a triangle. And this slanted line crosses at 2 on the x-axis and 2 on the y-axis. Now, if I want a specific equation for this line, remember that this line is the same as this line in the xy plane. And in the xy plane, z equals 0. So if I take the plane x plus y plus z equals 2, and I set z equal to 0, then that gives me the equation for this line. So this line is the line x plus y equals 2. Let's see if we can now set up the integral to calculate the volume. Using this formula, the volume is the double integral of the height function with respect to area. We'll have that the volume is the double integral of the height function, which was 2 minus x minus y, with respect to area, d something, d something. Drawing R again. This region is both vertically simple and horizontally simple, so it doesn't really matter which way we do it. A lot of students find it easier to slice regions vertically, maybe just because they do it more frequently that way. If so, then I'm going to be sending vertical line segments through. Those segments enter on the x-axis, which has equation y equals 0. And they're going to exit on this line. This equation could be written y equals 2 minus x. So setting up the bounds for y are going to be from y equals 0 to y equals 2 minus x. And on the x, I'm going to go from the smallest value of x in the region, which is 0, to the largest value of x in the region, which is 2. So this will be a formula for the volume of that triangular pyramid. Now let's work out this integral together. You might want to pause the video and see if you can work ahead of me for a little bit. But when you come back, I'm going to show you a way of doing the algebra which makes some of the work a little bit easier. So here we go. First of all, I'm going to integrate with respect to y, treating all the x's as constants. So that means I can treat this entire 2 minus x as a constant. So the integral of 2 minus x will be 2 minus x times y minus the integral of y with respect to y is a half y squared. And that's going to go from y equals 0 to y equals 2 minus x. Now, if you did this on your own, you might have written this as 2y minus xy, and that's perfectly fine. But keep watching. First of all, I'll plug in the y equals 2 minus x. So that gives me 2 minus x times 2 minus x minus half of 2 minus x squared minus, notice that when I plug in y equals 0, I just get 0. Well, let's look at this. 2 minus x times 2 minus x is the same as 2 minus x squared. And I'm subtracting half of 2 minus x squared. So 2 minus x squared minus half of 2 minus x squared is half of 2 minus x squared. So once again, if you were working ahead of me, then you probably had something equivalent to this, but it was all expanded out. And I'm going to leave it together. This is a fairly easy integral to do using a u substitution. Let me first of all factor the 1/2 out front. If I set u equal to 2 minus x, then du is negative x dx. So I'll multiply by a negative one here, and another negative one outside. So I get negative a half, the integral of u squared du. And let's look at the bounds. When x is equal to 0, substituting in here, I get that u equals 2. And when x is equal to 2, notice that u is equal to 0. So x equals 0 changed into u equals 2. X equals 2 changed into u equals 0. Now it might look a little bit odd to you to have the number 2 on bottom and 0 on the top. But remember, if we want to, we can flip those two and just change the sign in front. Let's do it. That'll give us positive 1/2, the integral from 0 to 2, u squared du. And then that's super easy. The integral of u squared is 1/3 u cubed. I'm going to take that from u equals 0 to u equals 2. So I get a 1/6 of 8 minus 0. Or 4/3.